In this video, we are going to demonstrate how to run Plan4res. If you need to install it, there is a video dedicated to the installation, which you can watch. So the first thing to know is that after the installation, you need to create a specific directory for running the model and for storing your datasets. So this can be created by using the user init Plan4res script, which is demonstrated in the installation video. So all the different datasets have to be in a directory called data, which is in your main my P4 user directory. You can see here the structure on the graphic. Here I have 3 datasets in my data repository. And each dataset has always the same structure. So now let's have a look at the input data. So Plan4res is composed of 2 parts of data. First is the yearly data, which are describing mainly the electricity demand per year. So this will be megawatt hours. The interconnections between the different regions. The installed capacities for all technologies, so that will be generation, but also storages. All the different costs of the technologies for operation and also for investment. And also, but this is optional, you can define a set of constraints for the different technologies. And when you run an investment case study, you also need to define bounds for the investment. Then the second part is the hourly time series, which includes load factors for the hydraulic inflows to the different reservoirs, the electricity demand, and also the renewable energy potentials, namely for the PV, the wind power, and the run-of-river. So in terms of data sets, the yearly data, which are stored in the CSV, Simul or CSV invest directories, you will find those 7 different CSV files defining all the different categories of data. So the first one, zone partition, defines the different regions. Zone values gives all the demand values, but also all the other coupling constraints if you are using them, like system services. And it can also be used to define some costs for and feasibilities. Interconnections define the max flows and the mean flows for the different interconnections between the regions. Thermal units is about all the technologies that in Plan4res are modeled as thermal units. So that will be the gas power plant, the coal power plant, the nuclear power plants, but also the biomass power plants and some others that are modeled like that. Seasonal storage includes the modeling of the hydro reservoirs which have seasonal capacities, so that the big reservoirs. In this modeling, we will only define 1 reservoir per region. Then renewable units includes all the renewable technologies like PV, wind power, but also run-of-river. And finally, short-term storage defines all the storage which is not seasonal storage, so that will be mainly pumped storage and batteries. And then in the time series directory, you will have 1 CSV file per variable and per region. Okay, so now we are going to look at how to run the different Plan4res modules. So here you have a summary of all the modules that are available. Today we will focus on the module starting on format. So the process is to first you have to create your input data set in the Plan4res data format. This can also be created by the create module from out of data files in the IMC format, but this will be explained in another video. Once you have created your input dataset, the format module will create the inputs of SMS++ in netcdf format, and then you can run the main computation modules, so the seasonal storage valuation, the simulation, or the capacity expansion, which will produce some outputs in the SMS++ format. And then you can run the post-treat module, which will produce some additional outputs. It will also convert some of them to the IMC format, and it will create some graphics. So running all the modules is pretty easy. You have to use the P4R function with P4R, name of the module, name of the dataset, and some options. And this can also be used if you are on a cluster with Slurm to run parallelization. In this case, you have to use the SP4 function, name of the module, name of the dataset, options, and an additional option -n with the number of nodes you are requesting. So we'll skip this creation step and go directly to the step to create the netcdf. Before looking at the CSV data, we will have a look at the configuration files. So the settings format, there is one which is called Optim, dedicated to creating dataset for the SSV, one with Simul, dedicated to creating dataset for the SEAM, and Invest is dedicated to creating dataset for the SEM. What is important here is these sections. Calendar, here it will define first if the dates are given with the day first, so this is 1st of January, or the month first, it will be January 1st. Here we see that the day is before. We have here the first and last time step of the available time series that we have, knowing that the scripts allow to use, for instance, a time series from 2050 on a case study in 2030, just taking the same time series. And here we see that our case study is starting mid of July, ending end of December, which is more than 1 year. And so it will take the time series from the mid of July to the end of December and copy the time series from the beginning again to get those 18 months. The other important things are the time steps. You need to define the time step for the seasonal storage valuation, which usually is 1 week or 1 month, here 1 month, and the time step for the simulation, which could be 1 hour. Here it's 1 week, so that it will be quicker. And then another the other interesting parameter here is scenarios, and you will have to select which scenarios from those available in your time series you are going to use in your run. So now let's have a look at the data. So first, the zone partition. This defines the list of regions that you will be using. It also it can define bigger regions. So the first column is dedicated to the granularity for the demand constraint. You may have other coupling constraints applying to different granularities. So here I could have a constraint applying to the continent granularity, and I see that all regions belong to the unique region world here. Zone values is dedicated to the data from the coupling constraints. So here I will use all the data for creating the demand. So those names are defined in Plan4res. You shouldn't change them. It is defined in the user manual. A total is the total demand for the region. And here it's the different shares of the electricity demand. And you can see that the sum of all this is equal to this one. And each share is associated to a time series, and so you need to have this time series. In the end, you define the values for creating an unfeasibility technology. If you don't have enough power, then you will use that unfeasibility technology, and its maximum power is very high, as well as its variable cost. Then we have one sheet per category of technologies. So the TU is dedicated to all that is modeled as thermal units. So here we see that we have different kinds of technologies per regions. We only have one unit of each in every region because it's not detailed, it's aggregated technologies per region. So we see that the max power is equal to the capacity. We have the variable cost and the investment cost, also the rate of emission. We could have other columns with some other constraints, which are detailed in the user manual also. The last two columns are used for the investment optimization, and they are the bounds of the maximum amount that can be added per technologies or that can be removed. So the other technologies are defined in a quite similar way. So here it's for the seasonal storage. So there can only be one storage per region. We have also a maximum power, a minimum power, which usually is 0, a maximum volume and a minimum volume. And then the inflows. So this is the total amount of inflows in the period. And we have also an inflow profile, which multiplied by this value will give the inflows at each time step. We also need to feed it with the initial volume, and we may have a efficiency for the production of electricity. Here we have the short-term storage, which usually is mainly pumped storage and batteries. It is also defined with the same kind of variables, the maximum power, maximum volume, efficiencies for producing electricity or storing it, a minimum power here, which is negative because we can consume electricity to store energy. Also the minimum volume and the same columns for the investment than we had in the thermal. And the last one is dedicated to the renewable generation. So mainly the PV, the wind power, and the run-of-river, which are defined with a maximum power and a profile also, which will be multiplied by the maximum power. So this will give the maximum power at each time step for this technology. And finally, we have the interconnections. So the interconnection, they have a name, but they also have a name of the region where the interconnection starts and ends, a maximum flow and a minimum flow, which can be different. The interconnections, they can go both ways, and they can be invested. So there can also be a maximum added and maximum retired capacity and an investment cost. So there we are for the data. And now we are ready to run the first module, which is the format, which I will do. So here I am in my data set, and I have this toy data set case study. So I will run the format on this case study for the optimization. I could also run it for the simulation or the investment. And here it's done, and I can see that now I have an NC4 directory with all those NC4 files which were created. So now that I have done this, I will be able to run the modules. So if I want to run SSV, I need to have created the netcdf files with the optim option. If I want to run scene, I need to have created them with the simul option. And if I want to run SEM, I need to have created them with the invest option. So as we have the data set for the SSV, let's run the SSV. There it is. It's going to be fast because the data set is very small. And then it's done. And now I have in a results repository. I have in particular those Bellman values out, which are the Bellman values which were computed. So now I will run the format for the investment to create an investment data set. And it's done, which means that I can run the investment. Oh, I don't need this. So it has started, and it will take a few seconds. And it's done. And so now I have result invest where all the results are filled. And so now the last step of my study will be to post-treat the results. So for this, I first need to fill a settings file, which is called post-treat Plan4res. The different sections that are needed here are mainly the first section called post-treat is dedicated to telling the script what to do. You do not have to do everything. So read is usually mandatory. Draw means that it will create graphs. LaTeX means that it will create a chapter in a LaTeX report, and IMC means that it will convert the output to the IMC format. Then I need to define the size of the graphics. So I will have, for instance, one sheet with one graph per stational storage. I have 3, so 2 columns, 2 lines is fine. And it's about the same for all the different categories. The demand, I have 1 demand per region. I have 3 regions, so this is fine. Then something important is in technos, I need to have the list of all technologies that are defined in my input data and associate to each of them a color. And finally, I can define some aggregated technologies in order to get some graphics that are more readable. So for instance, I defined the hydro, which includes the 3 different hydro technologies, and I want it to be blue. So let's run it. For the investment study. So it reads all the outputs. It creates some new CSV files. It is writing. Then it creates also a series of graphs. It does some computation from some synthesis outputs. And now it's done. So let's have a look at the results. So I have that results invest repo that has been filled, and we can see some new directories, image and out in particular. And in out, I have all those different CSV outputs that have been created that are some synthesis of the results, like the aggregated generation per region, the generation per region, things with the import-export. And I also have a series of graphs that we can have a look at. So, for instance, this is the average energy that was produced per aggregated technologies. So I can see in Rogander it was all this amount of PV in green, this amount of hydro in blue. So this one was the initial installed capacity before I run the optimization of investments. So the rural region is huge and the other ones are small, but this is due to the aggregation. I also can look at what has been invested. So I can see that mainly it's new batteries and a bit of new nuclear, which is the only capacity technology that could invest in this data set. And there are also some maps. So here it's the average flows between the different regions, but you can look at all the different categories all alone. And this is it for this demo. Thank you for your attention.